Hi guys, Dr. Justin Southey here. I'm going through your second semester test and I'm on question 15, which asks you to find the limit using L'Hopital's rule. Use this limit here. Now the biggest thing here just to bear in mind is notation. Notation. Make sure that your equal signs are in the right place. Make sure that you're writing the limit of something. What some of you have written is the limit as x approaches infinity equals. That's absolute rubbish. You've got to have the limit as x approaches infinity of something for it to make any sense. But let's jump right in and do this. The first thing we need to check is whether we can actually use L'Hopital's rule. And before we can use L'Hopital's rule, we need a 0 over 0 or an infinity over infinity, at least the limit of that. So let's just have a look here. X is approaching infinity, so x squared, you've got a really big number multiplied by another really big number, that's going to be even bigger, and when we raise e to the power of that, it's going to blow up extremely fast. So certainly the numerator is approaching infinity as x approaches infinity, and of course x cubed is approaching infinity as x approaches infinity. So yes, we've got a case here where this thing is approaching infinity over infinity, so we can use L'Hopital's rule. Now L'Hopital's rule says that if you've got this where you've got infinity over infinity, you can the limit of the fraction is equal to the limit of the derivative of the numerator over the derivative of the denominator. So let's go ahead and differentiate numerator and denominator. Now just note my notation here. So the limit of this is equal to the limit of, now differentiate e to the x squared. It's a function nested inside a function. It's e to the power of something, so the derivative of that is e to the power of the same thing, untouched. That's the outer function multiplied by the derivative of the inner function. Now the inner function is x squared, so we're going to multiply it by 2x and differentiate the denominator, and we get 3x squared. And here it's quite nice just to write that you're using L'Hopital's rule. Just make a little note in the margin that that's the step that you've used here. Now, what a lot of you did was go ahead and use L'Hopital's rule again, which we are going to do, but you ended up with a really horrible product rule here and quite a complicated denominator when you could have noticed, and only I think less than 5% of you actually did this, was first to cancel this x with one of the x's in the denominator, and that makes your lives a hang of a lot easier. So in the numerator we end up with 2 e to the x squared, the x is going to cancel, and we end up with 3x on the bottom. And again, we need to check that we can use L'Hopital's rule. We've got x is approaching infinity, so again this guy is approaching infinity really quickly, and of course the bottom is also approaching infinity, so we've got again infinity, that this thing is approaching infinity over infinity, so we can again use, and I'm going to write it here immediately, L'Hopital. We're using L'Hopital, and we're going to differentiate the bottom and the top. Now note my limit thing is coming all the way down in my correct use of equal sign. Okay, so the derivative of the numerator, well that's simply 2 times, now the derivative of this we've done already, that's e to the x squared times 2x, outer function, inner function, all divided by derivative of the denominator is simply 3. And now we're getting somewhere because we've got no x's in the denominator, which is really great. Let's just write this a little bit more neatly. We've got x approaches infinity, and we've got 4x times e to the x squared all over 3. Now, we're pretty much done, because now we just need to look at the top. We've got 4x, well x is approaching infinity, so that's approaching infinity. E to the x squared is just racing off to infinity. We've got two numbers multiplied together, they're both heading towards infinity, so they're going to just blow up even bigger, so the numerator is approaching infinity, and we're dividing by a piddling little constant of 3, which is certainly not going to slow down this race to infinity. So this whole limit is well, it doesn't exist. It doesn't exist in a very special way. We say that it's equal to infinity.